Elysium Lab. Thank you.
Thank
You,
you.
Aaron Clementi.
And today we would like to talk about why Bitcoin is not yet on the masses and how we can bring Bitcoin to many people and to the masses. Just to slide about ourselves, we are a startup based in Lugano. We are part of the main ecosystem for startup, Bitcoin, and also fintech. We are like 10 people from developers, designers, marketers, and business developers. We are also invested by Ethanity, that is the biggest accelerator in fintech in Europe, Fulgur, and probably soon also the new hub of Lugano Plan B, as a naive startup from Lugano. We know that more people are needed on the Bitcoin ecosystem, and we would like to build a new concept of self-custody that is really simple for everyone to jump on board of Bitcoin. What is the problem, we can say, of Bitcoin? I think Bitcoin is the biggest revolution after internet, but the success is not the same. After 15 years from internet was launched on the market, internet had 1 billion of users. Bitcoin, after 15 years, had probably less than 300 millions of users. That's not really a good deal. Even if internet 20 years ago were more expensive, more non-accessible, and less decentralized. Imagine how expensive it was 20 years ago to buy a computer or have an internet connection. Today, Bitcoin is really simple to have from a cost efficiency point of view or access of technology point of view. But why? Even less and less people have Bitcoin compared to internet before. Same input, same output. So things need to change. But what is needed to change? We think is an approach in a user-centric mindset that in Bitcoin is missing. So the technological point of view is great, but people need something else than technology. Also technology, but not only technology. The difference between internet tools and internet software compared to Bitcoin tools is that on top of technology, companies had to build a lot of layers on top of a technology, but not technological layer. There are many factors that we need to consider when we would like to use technology. Is our mind, is our body, is our beliefs, how we think about technology, how we interact with it, with many and many factors that are not technological. Is about our cultures, is about how we perceive the brands, is the design, is the user experience, is how we can adapt our neural programming languages to interact with the technology and how we can execute what we would like to do with this technology. So there are a lot of factors that are not technological and are even out of the hardwares, out of the protocols, and is how we use it. From our brain to our body, how we receive the communication from the technology, and how we actually give our input to the technology. So one product is more layer, from hardware to protocol to user interaction to the experience and how we change it, our behavior to the technology. How we can bring more people in this technology without changing the technology, because it's already great. We think that technology should follow the people and not vice versa. And this is what internet, we can say, internet companies did in the last 20 years. They follow user needs, as also Steve Jobs said. This is the funnel of a journey that new people and new customers have to do when they start or they would like to start a new product, from the awareness to the lead generation to customer and then advocacy. So from a newbie to a people to someone who also spread the words of Bitcoin and bring new people in this new funnel from outside. But how we can put these people in the funnel? The thing is, all of you have different needs, different behavior, different characters, and you need different solutions. So the goal is to make different experience and tailored experience based on your needs, on your mind, or your body, or whatever is it that actually is only yours. So we need to have customizable layers on top of technology. The experience should be different, even if the technology behind is the same. Our goals, but this should be the goals of any wallet, is that a new wallet should be easy enough that could be usable for my mom, but secure enough to be used by Riccardo Masutti. So that's the goal. How we can do that from a technological point of view, Gianmarco is going to tell that.
Thank you, everybody. Okay. Now that we have a, let's say, a market overview on the Bitcoin and let's say a little bit more in the infrastructure, I want to bring a new concept. Hopefully, you guys already know it. That is the ossification. So, ossification, generally speaking, in the internet protocols, is basically when a protocol becomes too rigid to handle new innovation and new standard coming into the market, and so it's not really able to change, so adapt to the change. I think it's actually a really interesting concept because we can take the same concept and apply it to Bitcoin. So in Bitcoin, we can actually see potentially two ways of the ossification. So it's a good ossification from one side, and it's a bad ossification from the other side. So the first side, the good ossification, is when we want to strengthen all the core principle of Bitcoins. So basically, it's solidifying the protocol itself and being able not to change, so we can have, let's say, a layer that is stable, is secure, and is not changing in an easy way, but require a lot of discussion, a lot of community engagement. And so it's where basically, let's say, we take Bitcoin as it is and we keep it stable. The bad part of the ossification in Bitcoin is where we apply the same thing from an interface standpoint. So the math principle of Bitcoin should remain the same, but at the same time, we should have a different approach on how we approach the technology itself. And so usually what happens is that the user experience remains stagnant, is not really moving forward, and so these things is not really helping the adoption of the technology, and it's not really helping Bitcoin to arrive to, let's say, the masses. So if we want to take this concept of ossification and bring it to the blockchain itself as a concept, blockchain can be seen as layers. So we have the first layer, that is infrastructure layer, where we have basically all the hardwares, where the nodes, the miners are basically working. And then on top of it, we have the consensus layer, that is basically the software, the core principle of Bitcoin. It's where we actually have the rules of the protocol itself. So from a good, let's say, ossification standpoint, the first two layers is the one that we want to keep it stable, not being able to change drastically and in a fast way, but we want to keep it constant, and we want to remain the same, right? But at the same time, the third layer is the application layer, and it's basically the user-facing application that we have, such as wallets or platform, that are basically bringing all the information from the consensus and, let's say, the blockchain itself to the user. And that's where I think the bad ossification is coming into the place. So that's where we need to work. That's where we want to change Bitcoin a little bit. It's not really Bitcoin, but the way we present Bitcoin to the people. And so basically, the idea is that we want to take the math principle behind Bitcoin the same, so we don't want really to change it, but we need to play around in a different way. Why? Because the things that we have at the moment in the market are not really working for traditional people, but are working for us. I guess everybody here is a little bit technical. And so we all know how to use this technology, but at the same time, we need to have a way to present the technology to the people in an easier way. Just a quick history about the wallet in the Bitcoin side, and then I leave the floor to Fadi to go a little bit deeper into the technical stuff. So generally speaking, in the Bitcoin wallet history, we started back in 2009 with paper wallets. It was the first implementation. It was basically bringing the private key to the user in an interface that they can save it somewhere, but it's not really usable, and it's not really feasible for traditional people. 2011, we have the first, let's say, desktop client, desktop wallet, huge advancement. We have a wallet into a device, but at the same time, still too technical, still not really usable for normal people. Then from 2014, we started to have different type of wallets. We started from hardware, then we moved to the mobile. The whole idea is to save the key somewhere. So generally speaking, you have the hardware you have in the device, or that is, of course, not connecting to the internet. And we have the mobile wallet where let's say the private key is stored on the device itself, so basically on a mobile phone. The idea and the underlying technology and the principle are always the same. So the math principle is the same. It's all based on elliptic core cryptography. So it's not really changing that part. But where they differ between each other is basically how they handle private keys. So the first two types are using private keys. Instead, from 2014, we started to have the BIP39, that is the standard of mnemonic sentences, or seed phrases as we usually call it. And it's actually a pretty huge leap forward for the Bitcoin because it's easier for people to understand, but it's not really usable because I cannot really store it anywhere, and I have a lot of problems that now Fadi is going to present.
So, yeah, seed phrases. The first problem we saw with seed phrases was that they are inconvenient. It's actually very annoying to store those keys, to write it down on a piece of paper. And one problem with inconvenience is that it's actually leading to insecurity, because if you don't store those those words, you are at risk of losing the whole, your whole funds. And yeah, this goes into the second topic, which is they are not that much secure. There are some controversies around the fact that they are secure, in the sense that we don't have, for example, the version number in seed phrases. And this can lead to security problems. Other problems may go around the fact that they use words, there is a fixed list, and yet we have different lists of words, for example, for different languages. And this can lead to insecurity on the one side. On the other side, it's also difficult to store securely. Generally, people say, write those words into a piece of paper, and yes, you are secure from the point of view of total device destruction, but you are not secure against water, for example, because you spill your glass of water on this piece of paper, and you lost all the words. So it's actually difficult to store securely. And because, as I said before, there are different lists for different languages, and because of the security problem, we also have that some wallets don't implement them. For example, Electrum doesn't use it, Bitcoin Core doesn't use it. And that means that they are not widely accepted, and they are not actually that much interoperable between wallets. So to solve those problems, our idea is that we have to go and start from first principles. So what's actually a private key? A private key is just, from a mathematical point of view, a private key is numbers. From computer point of view, they are bits, bytes. And you can actually generate with the line of code, for example. And yeah, there are some other line of codes if you want to create the WIF to store, to import in Bitcoin Core, for example. But if they are numbers, we can treat them as such and use all the body of literature that we have on numbers. We can see that we can have our private public key in our device and normal digital signature. You create your secret and public key, and you can sign the transaction normally using ECDSA in Bitcoin, of course, and then there is the verification algorithm. Everything is normal. On the other side, you can go full distributed and go with multi-party computation. Instead of key generation, normal key generation, you have a distributed key generation. And we know that a T out of N, for example, lets T parties to sign a transactions. And therefore, you have a specific signing transaction to sign the transaction. And it's okay, you can do with multi-party computation, but you can also go in, let's say, middle ground and go threshold signatures. Threshold signatures are, from a mathematical point of view, very similar to multi-party computation. There is not a hard line between multi-party computation and threshold signature. And also, multi-party computation is used for a variety of protocol, of course. We are talking just about digital signatures here. And, but the important thing to note is that thinking about the same protocol, maybe in two different ways, may lead to different problems and different proposed solutions. So let's start with Shamir secret sharing. I'm sorry, with multi-party computation. Generally, everything is based on Shamir secret sharing. This is a very well-known problem, very well studied, very well understood from the cryptographic point of view. The problem started to arise when you arrive in real life. So you have your key, you want to share your key, and therefore you are basically saying, yeah, I don't trust my friend with the key because he can steal my funds. Yet I do trust that my three friends will never collude to create the key and steal my funds. Okay, this is what you are saying. Or which is very difficult to understand for people. We are talking about maybe not technical people, and it's actually difficult to make them understand that there are different kinds of trust. Because generally, a trust with friends is very binary. I either trust them or not. And trusting them to not colluding is different to trusting them that they can store that key securely. They are different kind of trust, difficult to understand. Another problem is that, then those friends or nodes of a company need to be online when you need them. Because, yeah, if you need to store this key, they may be not online, so how can you reach them? Another problem is, what is the relation between the nodes? As I said, friends have a good relation between them, so problem. But also companies. What's the relation between the nodes of the companies that are generating and, storing your shares of the key? Well, because, yeah, we think, okay, of course, if the servers are from the same company, you may have a problem, and this is clear. But what happens when you have different companies, but those companies are under the same jurisdiction? So we have a government order, police order, and they have to fulfill this order, so they have to collude, and they can they can compute your key. Another thing may be, yeah, they are different problems, different companies, they are in different jurisdictions, and the problem is that they are using as hardware Amazon AWS. So you have potential, potential distribution, but in practice they are using the same company. What happens when, for example, they use different servers, but everybody is using the same software? You have a bug, and all software are affected by this bug. All nodes are affected by this bug, and therefore you have a problem because they can steal your key using the same bug. Okay, so let's think about the same problem in terms of threshold signatures. As I said, threshold signatures are basically you spread your key and you need just T out of N people to retrieve and do the signature. It's important to understand that using threshold signatures, you will have only one signature. This is different from multi-signature where you have one signature per key. You have only one signature here. Thinking of it in terms of threshold signature leads us to think also in terms of, let's say, hierarchical threshold signatures. you don't have to trust all nodes in the same way. You may have one node that you trust a lot, that you leave, and maybe this is your device, and you just need one key to sign and broadcast the transaction. You may have very less trust in other nodes, nodes 2 and 3, and tell them that, yeah, you may lose the key, but they can together sign transactions for you. So you are basically spreading the problem again. So you don't have to rely on them, but they are there if you need them. Of course, it's not a solution, a complete solution. So we have efficiency. The more nodes we have problem of efficiency. The more, and also efficiency in creating the signature. And we can also think about it in terms of accountable threshold signatures. What are accountable threshold signatures? Well, we have a normal threshold signature protocol. We have that the protocol aborts. We don't know who is the faulty node. With accountable threshold signature, we can know which node is to blame. By knowing that, we can basically remove from the set of n parties that we want to sign, leave them to sign. What's the problem with accountable threshold signatures? Privacy. Generally, the node to blame, the set of people needed to sign are public when you use accountable threshold signature. And this is a problem because you're basically revealing your setup. But we are improving them because there are recent papers about that are more private. And the other problem is that accountable threshold signatures are not always compatible with Bitcoin. And the third problem is that sometimes they involve zero knowledge proof, which is not that efficient. We also have other possible ideas, which are maybe not directly implementable in Bitcoin, but that can be used in other layers. For example, threshold ring signatures. We don't have ring signatures on Bitcoin. Ring signatures are generally used to mask the sender of the transaction. But using threshold signature, you can have threshold signature even in a ring signature scheme. And finally, we can have threshold blind signatures. Blind signatures may be used in other layers in Bitcoin. And the problem with blind signature is that you have privacy, but you lose in security due to centralization. And by using threshold blind signature, you may partly solve this problem by spreading this signer into multiple signers. So to wrap up, we think that by seeing private key as numbers, we can access a whole new literature in order to make people more at ease in using these transactions.
Okay, so now that you also have the technical background and the idea, technical knowledge, let's say, I guess you already have it. But the real question is, what if there was a solution that is taking into consideration all the flaws and the issues that the technology at the moment has in terms of interface? So using seed phrase, it's too technical, it's ugly to see, and it's also there's a really bad user experience. What if there is a solution that is secure, so it's using the same math principle as Fadi was presenting, but at the same time is using the same non-custodial standards that we have at the moment in the market, following the wallet that are already in the market, but at the same time is also usable and simple as an interface, and at the same time is also independent from other external services like server or third-party provider. We as Elysium are trying to create this, and why? Because we think that Bitcoin should not be stored in a bank or in a third-party provider. We don't want this. It's exactly what Bitcoin is trying to solve. So deleting and removing the intermediaries between financial transactions. And we want Bitcoin to stay non-custodial, as I said, and we want to give the people a tool, an easy tool to escape the fiat world. So thank you everybody for having us. Hope you like the talk, and really looking forward for your feedback whenever we launch. Thank you so much.